Hi students, this is Mr. Yao. In the last lesson, we have learned about the geometric sequence with its recursive formula. And in this lesson, we're going to learn about the other formula. But first, let's review. Here's a recursive formula for a geometric sequence. A sub 1 is given as 2. A sub n is a sub n minus 1 times 10. And it's asking to find the first four terms and then a sub 10. So let's have a look. A sub 1 is given. And a sub 2 is just going to be a sub 1 times 10, which is going to be 20. Then a sub 3 is going to be a sub 2 times 10, so it's 20 times 10. And that is 200. A sub 4 is the previous one, which is 200 times 10, which is 2000. And if you follow the same pattern, we can keep going. A sub 5 should be 20,000. A sub 6 should be 200,000. And when you actually get to a sub 10, it should be 2 with 9 zeros. And that would be 2 billion. Okay, so just like when we learned about arithmetic sequence, you might have noticed recursive formula is also even for geometric sequence. So in order to find the fifth term, you need to multiply by, the ratio 49 times to actually find the previous 49 terms. So we need a more direct formula. Similar kind of exploration. 3, 6, 12, 24. This is not arithmetic, just it's supposed to be geometric. Okay, the ratio 6/3 or 12/6 or 24/12, they're all going to give us a 2. How many r's are between a sub 1 and a sub 2? There's only one between a sub 1 and a sub 3. There are 2 of them. And a sub 1 and a sub 4, there are 3 of them. So here, that's how you know, times 1, 2, times 2, 2, and times 3 2s. That means before a sub 1 and a sub 199, there will be 198 ratios. So the conclusion, if we want to get to the nth term, we're going to need to take the first term and multiply by n minus 1 of the common ratio. So it's kind of very, very similar to the arithmetic sequence. Here's the explicit formula for a geometric sequence. We need the first term. They're going to use the first term multiplied by the ratio n minus 1 times. So technically, it's supposed to be times r times r times r times r. And you're multiplying by r n minus 1 times, which is the same as r to the n minus 1 power. That is the explicit formula. So now let's practice writing the explicit formula. A sub n is a sub 1 times r to the n minus 1 power. For example 1 and 2, everything is given. So a sub n equals 2 times 5 to the n minus 1 power. Example 2, b sub n equals 10 times negative 11 to the n minus 1 power. However, the important thing that I have emphasized in previous units, when you have a negative, you got to put it inside parentheses. Moving on, example 3 and example 4. A sub n, well, we need a sub 1, which is 4, and then we need r. We use the next term divided by the previous, so negative 12 divided by 4, or 36 divided by negative 12, or negative 108 divided by 36. They're all going to give us negative 3. So 4 times negative 3, don't forget to put parentheses, n minus 1 power. Example 4, a sub n equals, well, a sub 1 is an 8. A sub 2, not a sub 2, r is 2/8, or 1/2/2. They all simplify to be 1/4. So 8 times 1/4 to the n minus 1 power. Same thing here, just like the negative, we need to make sure the negative sign is also included in the part that's being raised to the n minus 1 power. Same thing here, the 1/4 is the whole thing that's being raised to the n minus 1 power. So 1/4 also needs parentheses around it. The nice thing about the explicit formula, of course, you can get to the term that you want by plugging in the index. Example 5 and 6. You are given the a sub 1 and the r, and is asking to write the first 4 terms. So let's actually find the explicit formula first. A sub n equals 13 times 7 to the n minus 1 power. A sub 1 is given. A sub 2, 13 times 7 to the 2 minus 1 power, which is 13 times 7 to the first power, and that is 91. A sub 3, same things, 13 times 7 to the, this time 3 minus 1 power, so it's 13 times 7 squared, and that is 637. a sub 4, 13 times 7 to the 4 minus 1 power, which is 13 times 7 to the third power, and that is 4459. Okay, example 6. Same thing, b sub n equals b sub 1 is 4 times, it's a negative 4 ratio, so make sure you put it inside parentheses, to the n minus 1 power. B sub 1 is given. This time, let's actually go backwards. B sub 4 is 4 times negative 9 to the 4 minus 1 power. So it's 4 times negative 9 to the third power, and that is negative 2916. Next, B sub 3, that's 4 times negative 9 to the 3 minus 1 power, which is 4 times negative 9 to the second power, and that is 324. So this is why you have to make sure the negative sign is inside the parentheses. You see, when it's a square, you actually get a positive answer. And when it was cube, you actually do get a negative answer. Okay, b sub 2, 4 times negative 9 to the 2 minus 1, so it's 4 times negative 9. That is just negative 36. That's example 6. Moving on, example 7. It's asking you to find a sub 9, and it's given a sequence. Let's actually try to get the explicit formula first. A sub 1 is 9. As for r, you can use the second term divided by the first, so 6 over 9, or the third term divided by the second, which is 4 over 6, and they are both going to give you a 2/3. That is the ratio. So a sub n equals 9 times, don't forget to put the fraction inside parentheses before we raise to the n minus 1 power. So it's 9 times 2/3 to the n minus 1 power. It's asking to find a sub 9, so that is 9 times 2/3 to the 9 minus 1 power, which is actually to the 8th power. And get a fraction, simplifies to be 256 over 729. There you go, that's example 7. Example 8. A sub 1 is 6. R is second term divided by first, or third term divided by second, or even the fourth term divided by the third. They're all going to give you a ratio of 3. So a sub n equals 6 times 3 to the n minus 1 power. Let's put in 11. 6 times 3 to the 11 minus 1, which is 6 times 3 to the 10th power. And that is 354,294. There you go. But these numbers can get quite big. So let's say now I also ask you to find a sub 21. You can pause here and try to find it. Hopefully you have tried it. It's going to be 6 times 3 to the 21 minus 1, which is 6 times 3 to the 20th power. The issue is, after you type in your calculator, you're getting something like this. 2.09207, then a bunch of other digits, E10. That actually is scientific notation. E10 is telling you the exponent is a 10. A lot of time when it's asking to represent it using the scientific notation, you're going to be asked to round to 3 decimal places. So 2.092. The E10 actually means times 10 to the 10th power. It's always going to be a base 10, and whatever the number is after E, that is going to be the exponent for 10. So that's the answer for a sub 21. Moving on, example 9 and example 10. This time you're given one formula, it's asking to find the other. First one, you're given the a sub 1 and the recursive formula. So a sub 1 is already there. This is going to be our R, explicit formula, a sub n equals negative 7 times negative 7 to the n minus 1 power. Technically, because these are both negative 7, you could simplify it, which means you actually have one extra, so it's just negative 7 to the n minus 1 power. But let's keep it this way, because that looks more like your explicit formula, making n minus 1 as the exponent. Example 10. First, find a sub 1. That is 9 times negative 15 to the 1 minus 1 power. So it's 9 times negative 15 to the 0th power. Anything to the 0 power is just a 1. So the whole thing is just a 9. Then the second part, a sub n equals a sub n minus 1 times whichever part has the exponent. That's our r. So times negative 15. There you go. That's example 10. The very last question is just for you to try. That's the kind of question we're going to be working with in the next lesson. So that is everything for this lesson. Thank you.